So this is called Changing Story of Twin Paradox. The twin paradox is a problem from Einstein's relativity. Roughly speaking, the twin paradox is the story that one twin stays at home and the other twin goes off in a rocket and comes back. Then when they compare clocks, they're different. Now the story has changed over the years as to how Einstein relativity deals with it. The scientific method is an ongoing process, and the thing to note is there's a box or circle you get to where you refine, alter, expand or reject a hypothesis, and that's where they start making amendments to their theory. So when they start talking about the twin paradox, what they're doing is going in this circular loop, and then they're changing their story. And this is where I'm highlighting the relevant box. So for many people, it's natural to keep revising the theory. In the case of the twin paradox story, it keeps getting revised. As an example of the changing story of the twin paradox, I'm looking at this book by James Coleman called Relativity for the Layman. And this book has been brought to my attention. It has changed the story of the twin paradox under its different republications. Coleman, that's the author of the book, in his first edition of the book in 1954, mentioned the paradox but did not really offer much in the way of a solution. He says, this is the paradox at the end of a rocket ship. Will the people on Earth be older than the rocket men? So first to note, he's talking about more than one person on the rocket. Or will the rocket men be older than the people on Earth? Question mark. Both views are correct according to the special theory, and the special theory is special relativity. Yet they are contradictory and both cannot be true. Coleman openly admits that the theory requires a contradiction! However, Coleman does later change his mind. However, it does indicate that Einstein's relativity was not a fully formed theory. You get in all these sort of revisions, amendments to the theory, and this is what's happening in the box, which is highlighted earlier, where you get to refine, alter, expand or reject a hypothesis. In that box, when the physicists go around in their circle for the scientific method, they start changing what they're saying. So going through the two different versions of Coleman's book. The 1954 version is here on the left and the 1990 version is on the right, and I'm comparing these two versions. So the 1954 version, after talking about time, says the fact that time appears slower on the other's system to two observers travelling with a constant velocity relative to each other has given rise to the famous time or clock paradox. To illustrate, we must first make clear that when time appears slower on a moving system, not only do the clocks on that system appear slower, but all time processes are slowed. And he's not calling it the twin paradox, but he's calling it the time/clock paradox. But it's more commonly known as the twin paradox nowadays. And he goes on to say, this means the digestive processes, biological processes, atomic activity, all are slowed down. And so what he's saying is clocks are slowed down and assumes everything else is slowed down as well. However, often there's arguing that there's only the clocks that slow down and time itself has not been slowed down. And that's what many of us in the dissident movement argue about. It's only the clocks that are different and time itself is not being slowed down. But I shall pass on that issue and just carry on with the assumption he's making that the clocks are showing actual time, and it's not just an effect on the clocks. And the 1990 version of the book says the same thing. The 1954 version carries on and says, with this in mind, then the clock paradox is stated as follows. And what it's going to do now is give a particular example. A rocket ship manned by several men is all set for a space trip to Arcturus in the constellation Bootes, the herdsman, which is 33 light years from the Earth. If the rocket travels at velocity close to the velocity of light, it will arrive on Arcturus a little over 33 years later Earth time, and if it returns immediately, it's still going to take 33 years to travel that return trip. It will arrive back on Earth about 66 years after leaving the Earth. And the 1990 version says the same thing. The 1954 version carries on and says, since the rocket has been moving with a high velocity relative to the Earth, all time processes in the rocket have been slowed down considerably. It will not seem to the men on the rocket that it took 33 years to make the one-way trip. In all probability, they will be pulling into the region of Arcturus just about the time they get gurgles in their stomachs to tell them they're hungry. So it's a very fast trip according to the people on the rocket. And when they arrive back on Earth, it will seem to them that only a day has elapsed. He's not really providing the mathematics for this, but this is the setup he's proposing, that it's 66 years Earth time, but for the people on the rocket it's only about a day or so. And he carries on, but when they arrive back on Earth it will seem to them only a day has elapsed, but to the people on Earth it will have been 66 years. When the men alight from the rocket, they will find that their wives, who were young when they left them, are now too old and feeble to come and meet them, or still worse, that they have long since died of old age. And some of the men might even be faced with the startling prospect of having to greet a hitherto unknown son or daughter who is 66 years older than they. It might seem enticing to keep young by travelling about in space, but it does have its complications. And the 1919 version says the same sort of thing. The 1954 version continues, but this isn't all. We found from the first postulate, that's the postulate of special relativity, that all motion is relative, so we can really view the space trip as if the rocket stood still but the Earth went off in the opposite direction on a voyage through space and back. So relative to the people on the rocket, it's the Earth moving away from them and then coming back to them, and not from the Earth's point of view, where it's the rocket going away and coming back to the Earth. He continues, the theory now says that the time processes on Earth will be slowed down relative to those in the rocket. Hence, when the Earth returns to the rocket 66 years later, everyone on Earth will now be but a day older, while the men on the rocket will be 66 years older. From this point of view, the young wives and children will now find themselves with old men for husbands and fathers. So, from one point of view, it's the people on Earth that is aged by 66 years, and from another point of view, it's the people on the rocket that have aged 66 years, and that is symmetrical time dilation. When you've got the relativity principle applied, then both frames are equally valid. And from this point, this is where the two versions deviate. The 1919 version does not say that, which has just been stated. Continuing now with the 1954 version. So the 1954 version says, this is the paradox: at the end of such a rocket trip, will the people on Earth be older than the rocket men, or will the rocket men be older than the people on Earth? Both views appear to be correct according to the special theory, that's of relativity. They are contradictory, and both cannot be true. And that is what I said: symmetrical time dilation. Each clock is slower than the other, and that is the paradox. How can both point of views be correct? One point of view has the rocket people being older, and the other point of view has the people on Earth being older, and so special relativity breaks down there. So he continues, with the advent of rocket research in recent years and its use in space travel in the foreseeable future, considerable interest in this clock paradox has been regenerated. Not only has the paradox been seriously debated in scientific journals, but many people are claiming in all seriousness that people who continually engage in space travel will remain perpetually young. This is not true, as the following explanation of the apparent paradox will now show. So my comments are, after admitting the contradiction, says it's an apparent paradox. So presumably means when it says contradiction earlier, meant not really a contradiction, but instead just an apparent paradox, ? As he continues, although the special theory does not predict a slowing down of time processes when two observers are moving relative to each other, it applies only when their relative velocity is constant. It does not apply in the case of a rocket taking off from the Earth and later landing, because in the launching and landing processes the rocket is accelerating and decelerating, i.e. its velocity is not constant. Here the general theory would apply, and it has been shown that the slowing down of the time processes which occur in the rocket when, after takeoff, it is moving with constant velocity relative to the Earth are cancelled out when the rocket's velocity is changing during launching and landing. Hence there is no permanent effect and of course no paradox. So it's not very clear what is being said here and what is supposed to be meant by cancelled out. Could mean that both clocks are now the same or something like that, ? So it's a sort of bluff. In the 1954 version of the book, he's given sort of a bluff. He's saying the special theory doesn't deal with acceleration, which is special relativity, saying special relativity doesn't deal with acceleration and deceleration, and he says you need general theory for that, which is general relativity. So he's bluffing off by saying special relativity doesn't deal with it, but general relativity does, and there's some sort of mysterious cancelling out effect. He continues, it might be argued by some that if a rocket or some type of rocket space platform, once it has launched, were continually to circle the Earth and at the same speed without ever landing again, the effect would be, in this case, be permanent, and the fountain of youth could be attained. The reasoning is fallacious, so he doesn't believe in that point of view. However, because a rocket circling our planet with constant speed is not travelling with constant velocity. Constant velocity means that the speed and direction are constant. Here, in order to keep the rocket moving in a circle, a force must be applied which results in an acceleration, and the special theory and its predictions would not apply. So once again he's saying special relativity does not apply, and you would need to go to general relativity. So what he's meaning is when there's a false special relativity does not apply, question mark. In my point of view, the 1954 version ends in a confusing mess. It's making all these claims of you can't deal with the twin paradox by special relativity, you have to go to general relativity, but it's making a confusing mess when it does that. So now going to the 1990 version, it admits that changes were made. So this is from the 1990 version in the preface to the revised edition. It's admitting that it's rewritten what it claims about the clock paradox, which is now commonly called the twin paradox. Starting the preface, it says, in the 15 years since this little book was originally written, many developments have occurred which relate to relativity. In most cases, these have been the application of later scientific discoveries and new techniques to the original predictions of the theory. In the case of the time or clock paradox, he's still calling it that, then instead of what we more commonly call it the twin paradox, the long smouldering disagreement regarding its explanation finally erupted in 1957 to 1959 in a voluminous outpouring of papers on the topic. So he's admitting that there was a lot of disagreement on the twin paradox. I have taken advantage of the clarification of this topic, which has resulted and have completely rewritten the section dealing with it to conform to the present views of the majority of those theoretical physicists who are deemed to be most knowledgeable about relativity. So now he's referring to there being a majority point of view of what the twin paradox has, and he's not going to tell you what the minority point of view on the twin paradox is. So the thing to note there is physics is biased. It's only going to tell you a majority point of view. He's not going to tell you the minority point of view most of the time. The mainstream is just going to stick to saying what the majority want to believe and not going to admit to there being any controversies and people having disagreement. Also, there was a person, Herbert Dingle, who was complaining about the twin paradox in the 1950s and all that voluminous outpouring of papers on the subject might have been caused by him disagreeing with the twin paradox. So this is Herbert Dingle, as mentioned in Wikipedia, and it goes on to point out the second dispute he had began in the late 1950s. Following Dingle's retirement and centered on the theory of special relativity. Initially, Dingle argued that contrary to the usual understanding of the famous twin paradox, special relativity did not predict unequal aging of twins, one of whom makes a high-speed voyage and returns to Earth. And so my comment on that, that's the second big issue that Dingle was arguing about. Wikipedia goes on to say other things which I disagree with, and ideally I need to do a video on Dingle. Anyway, back to the 1990 version of the book. It says, in all cases, the more recent tests of the theory of relativity have, without exception, further verified the basic predictions of the theory. And I've noted a typo there, and it should be saying the fundamental theory and predictions as originally announced by Einstein thus remain unchanged. And so when they say the theory of relativity, well, that can refer to special relativity or it can refer to general relativity, or it can refer to special and general relativity. So the term theory of relativity can be quite vague, and I dispute the claim of verifying the theory. I dispute because the theory is vague and mainstream is putting different interpretations onto it and need a properly defined theory if going to test it. So as I've already now pointed out, you've got all this vagueness. It goes on to say some of the changes made in the text represent an attempt at further clarification of points raised by many readers who have written me. While every attempt has been made to make this revision as clear as possible, it is not claimed that the result is the penultimate introduction to relativity. So readers are invited to continue to forward any suggestions for further improvement or any questions which still remain after a careful reading of the text. So my comments are, so omits to revision, so it's a change of theory, my point of view. What's saying about the theory of relativity not going to be the same as what's said in the 1954 version of the book. There are people who claim that it is okay to revise the theory. I say it is not, in the sense that if revising the theory, then have to admit it's not the same theory. What's saying is the theory in 1954 has now been revised to be being a different theory. Those revising relativity are loath to make admission that the revising means they keep changing the theory. That makes their actions deceptive, and it's been highlighted here in the twin paradox. What he's saying about the twin paradox has undergone a revision, and my point of view, that has been a change of theory. The 1990 version will be using this equation for the time dilation. The 1954 version says, but this isn't all. We found from the first postulate that all motion is relative, so we can really view the spaceship as if the rocket stood still, but the Earth went off in the opposite direction on a voyage through space and back. The theory now says that the time processes on Earth will be slowed down relative to those in the rocket. Hence, when the Earth returns to the rocket 66 years later, everyone on Earth and so forth, etc. And now in the 1990 version, instead of saying that, it says one of the results of the time prediction, which has been a source of great puzzlement and some disagreement, i.e. they didn't agree. The physics community were in disagreement about the twin paradox. Since its introduction is the clock paradox, also known as the twin or time paradox. It can be explained best by an example. 1990 version goes on to say this: we assume we have twins, one of whom makes a trip to a distant star and back while the other remains on the Earth. We further assume the star to be at a distance of 4 light years from the Earth. So he's given a different example to what was given in the 1954 one. We further assumed the star to be at a distance of 4 light years from the Earth, and that the rocket twin travels at an average velocity of 4/5 that of light. So he's not going at light speed now, he's going at a fraction of light speed. The total time for his trip then will be about 10 years Earth time. The question of interest is how fast time flows for the rocket twin as compared to the Earth twin for the trip as a whole. Inserting for v, which is the velocity, the value of 4/5 that of light speed. In equation 6 we find t prime is equal to 3t divided by 5. That's the equation earlier I showed you for the time dilation. This says that on the average time for the rocket twin moves only 3/5 as fast as it does for the Earth twin. This means that while the total trip took 10 years according to the Earth twins clock, it took only 6 years according to the rocket twins clock. Thus, when the twins are reunited again on the Earth, the rocket twin will find that he has not aged as much as his stay-at-home brother. In fact, the rocket twin will find that he is actually 4 years younger biologically. He's still thinking that there is an effect on time, when many in my distant community argue that it's just an effect on the clocks, but carrying on with his point of view on that. And he says, now for the paradox: since all motion is relative, why can't we assume that it's the Earth which moves off into space in a direction opposite to that of the rocket originally and returns while the rocket ship remains at rest? The Earth would travel a total distance of 8 light years at an average velocity of about 4/5 of that of light speed, just as the rocket did. This appears to be justifiable mathematically because in equation 6 the change would be to replace v by minus v. The result would not be changed, however, because v is squared in the equation. If we accept this opposite view of the entire situation, then the mathematical prediction from the time dilation formula is reversed. Now the Earth twin will be 4 years younger than the rocket twin when they get together again. So we got the problem of who is the older twin. So the paradox is that when the rocket twin takes this particular trip, he returns 4 years younger than his Earth twin. But if we assume that is the Earth which moved off into space and returned, it's the Earth twin who returns physically younger than the rocket twin. Obviously, each cannot be younger than the other simultaneously, so we have a contradiction. This constitutes the paradox. Admitting to there being a contradiction and hence paradox, ideally that should mean the theory that gives contradiction stroke paradox should be discarded, but does not take that route. Instead tries to explain away the contradiction stroke paradox, treating as an apparent contradiction stroke paradox and not as an actual contradiction stroke paradox as per the usual mainstream point of view. And he carries on, the solution to the paradox is that both views are really not interchangeable, as we have assumed. So earlier he's assuming that the views are interchangeable, of that of the Earth observer and of the rocket observer. He was assuming that those views are interchangeable, and now he's worked out they're not. And so he says there is no paradox at all. In other words, the two situations are not symmetrical and therefore not reversible mathematically. So basically saying the math he did wasn't correct. The reason is that the rocket undergoes acceleration and decelerations during the trip, whereas the Earth does not. The assumption that the Earth goes out into space and returns rather than the rocket is not valid, because the Earth would have to undergo the necessary accelerations and decelerations instead of the rocket, which we now know it does not do. So he's talking about accelerations and decelerations not being relative. However, I'll refer you to what he said earlier, quote, all motion is relative. So basically he's contrary to what he said earlier. He's now treating acceleration and deceleration as not being relative. So we have the relativity principle, and suddenly acceleration and deceleration are not relative, and the relativity principle is not supposed then to apply to acceleration and deceleration, but from the way he's been writing about things, it is completely a mess. And so my comment is, it is the usual trick of relativists, those who believe in Einstein's relativity, to contradict themselves. And most of the time they seem totally unaware that they are contradicting themselves. Other tricks they use include saying things that are ambiguous stroke vague. So he carries on and says this: of course, if the Earth were to actually make the trip by undergoing the necessary accelerations and decelerations while the rocket remained at rest, then in this most improbable case it would be the Earth twin who would be the younger physically when they were reunited. It is also possible to envision the perfectly symmetrical case wherein the time dilation effect would be the same for both twins, so they could be each aged at the same rate. This would occur if the twins had identical rockets initially at rest at the same point on the Earth and then travelled off into space in opposite directions. So he's now considering a different case for the twin paradox, where the twins are in, both twins are in rockets and they're moving relative to each other, instead of one twin being on Earth and the other twin being in a rocket. So my point of view is just going off on a bit of a diversion. And this is where I make note all this is a bit of diversion, because I just want to stick to the original case. And the original case is the one twin on the Earth and one twin in the rocket. And he goes back to the original case. He says, returning to our original case now, the rocket could not avoid the deceleration and acceleration necessary at the distant star to reverse its velocity by turning in a large semicircle. In order to turn in a circular arc, a sideways force must be imparted, which results in an acceleration at right angles to the direction of motion. Thus, the use of some type of acceleration to reverse direction and velocity is always necessary. My comment is, so basically saying, in the original case, there is no symmetrical time dilation case. It is always asymmetrical time dilation, because always some sort of acceleration stroke deceleration involved which breaks the symmetry. The relativity principle is the symmetry case, where you're considering symmetrical time dilation. So he's basically saying the relativity principle does not apply to the twin paradox. He carries on, a rigorous mathematical treatment of the situation using equation 6, that's the time dilation equation I showed, plus the other formulas which apply under the conditions of the special theory, which is special relativity, leads to the inescapable conclusion that less total time for the round trip will elapse for the space travel, regardless of how he measures time, than for the Earthians, i.e. the people on Earth. Any further Spacetarian, the astronaut, the space traveller, will always return to Earth at the top end of his trip, not having aged as much as the Earthians, people on Earth, who stay behind. The total amount of the time retardation predicted by the special theory, which is relativity, for the Spacetarian, the space traveller, will depend, of course, on the velocity of the rocket relative to the Earth, assumed constant, and the total distance of the trip. So you note the trick of saying a rigorous mathematical treatment. The book is not going to go into detail of explaining what that is, but basically saying it's complicated, so not going to go into details about it. The book is then going to bring in such issues as relativistic Doppler effect, or extra issues to start complaining about. All those issues introduced so the book can conclude. The above discussion also indicates why the physical situation is not symmetrical for both twins, and why the total time for the trip is different for each. I.e., he wants the twin paradox to be asymmetrical and not symmetrical. as I pointed out, is the symmetrical case. That is the relativity principle, and if you're not symmetrical, then it's not obeying the relativity principle, and thus stop sticking with what special relativity wants to say. The trick then with the twin paradox is to not stick solely in the context of special relativity when dealing with it, but he's not explicitly going to admit things like that. Einstein's relativity is special relativity and general relativity. When I have troubles dealing with a physical scenario in context of special relativity, then I'm supposed to go to general relativity, and that is a trick that they use in such things as the twin paradox. When they have difficulty in dealing with the twin paradox in the context of special relativity, they then try to pretend it's dealt with in general relativity. But really, does the mainstream admit in those terms that that was what they're doing? So they engage in subterfuge. And the subterfuge continues when the book concludes. The results of the particular example cited above, wherein only the time dilation of the special theory at special relativity was considered, are thus essentially correct, and only the special theory is needed to discuss the clock paradox fully. That is false. The book had to drop dealing with the relativity principle when dealing with the twin paradox, and dropping using relativity principle meant it was no longer being dealt with fully in the context of special relativity. Thus, several possibilities present themselves. First possibility, claim the twin paradox was being fully dealt with in the context was either I, a lie, or I, a mistake made by the book when they didn't properly understand relativity. Second possibility is the book had now revised special relativity, with special relativity meaning something different to what is commonly meant to mean. Anyway, of course, much of the problem is with the vagueness of how the relativity principle is stated. Presumably, the relativity principle is only dealing with constant velocity and not dealing with acceleration and deceleration. But that's what is meant. Then it's not often being stated like that. And as noted, Coleman sometimes thinks it applies to all motion, which would mean applies to both velocity and acceleration and deceleration, which would be contrary to a revised version, which deals only with the velocity and not acceleration. Thus, some subtle way, Coleman has revised relativity between the two versions of his book, a trick the mainstream often uses to make subtle amendments to relativity. And that's it, thank you. That concludes my little talk on it. It shows you the mess that the mainstream makes when dealing with the twin paradox.